我最后找到了。哦，你居然有，我发给你了。好的，谢谢。Good morning. Well, I'm Li Xiang. Well, my topic today is involving Sigma that's adopting Kubernetes. And let me introduce myself. I'm from Ali Group and I'm an engineer. Previously, I was focused on Kubernetes, and from 2013, I was working on etcd project, and later in Kubernetes, I was leading the team. And this year, I joined Alibaba and to do the cluster management Sigma system, and use it as the engine to evolve into the new Kubernetes. Well, my topic today will actually cover three aspects. First is the background of Sigma and our team, and so that everyone can be better knowing why we want to evolve into a higher system. And the second part, we want to talk about adapting and extending Kubernetes to adapt to our environment. And later, I will spend some time to talk about the challenges that we might meet in the future. 怎么两个都是中文 First, I will introduce the Sigma. As you can see on this slide, you can see it's quite important in Alibaba's whole architecture. Well, actually, it's connected to the bare metal cluster and the virtual machine cluster in the cloud. And above that, there was a container and the workflow. That is a major part of Alibaba's whole architecture. And we're doing the following. We have the following responsibility. First is about to manage a larger number of machines and all its kind of resources, including computing resources and physical and virtual resources, maybe in virtual resources that are in the cloud, and other interface. And also Sigma also schedule this kind of resources when users requested to use such kind of resources, and Sigma will do the struggling system, and we also do the maintenance and strengthening work. We want to offer automatic maintenance with Sigma, and we use a container to do the runtime. A typical workload used by the e-commerce, like Taobao and Tmall, Alibaba, we all use the same workload, and we also have some kind of computing workload like AI or CI/CD and online services. Well, CI/CD do not that sensitive to latency, and we also have some database and the second struggling system that's above Sigma, so that Sigma actually manages a large amount of machines inside Alibaba, and we're serving over 60 BUs with high quality and storage resources, and we also support the November 11th, and this year we actually work on the stack establishing. Well, later I will talk about the scale of Sigma. And this data was released last year. Well, I believe the data in this year will be more impressive. And we found that in 3 minutes we achieved 10 BGMV, and we concluded 32,500 transactions per second. And for the scale, we often deploy 1,000 nodes. And in Alibaba, we have over 10,000 applications that are deployed on Sigma, and these applications produce like 1 million containers that were operating every week. And if we will check the data that performed every day, we'll find the data will be much more impressive. Well, I will give a brief introduction to Alibaba. As I already mentioned, Alibaba is operating on the level of containers. Well, previously, actually, Alibaba was evolved from the virtual machine. And at that time, all this kind of application was matrix application. At that time, we want to split it into small applications to deploy them. So the first stage, we used the virtual machine to package each application so that we can have more efficient scheduling, and each application can have isolated operating spaces. Well, when using VM, we found the following issues. First, when they provide the basic functions, we found some overhead. In 2011, when we used the VKM, if the speed is about 32, well, we may waste about 8 on the Hyper-V. Well, for the second issue is that the business run on that may not have a satisfactory visibility. We cannot be clearly aware of the status of this kind of operation or these businesses. So that at the time, we wanted to explore a new technology to reduce the overhead caused by virtualization, and on the other hand, we want to have the information of the GPU running in each app, so that at that time we developed the T4 based on the virtualization, and it's quite similar to the concept of container. When we adopted the T4 technologies, we do not want it to change the habits that operating the maintenance and operation of VM, and at that time we offered a dedicated IP and isolated system and resources. So that migration was quite smooth. While in 2015, while the Docker or OCI was quite popular. So at that time, we want to build a container and have that kind of concept. At that time, we want to have a standard image, to have a standard way to distribute these kind of images. And we want to describe these images with a standard format. So that time we developed the Ali Docker, and we made our attempts and exploration. And so the features of T4 was incorporated into the new container, and which forms the foundation of the porch that we launched later. Well, that was evolving of the container. Well, here I would like to introduce the cluster management. Well, in 2013, we have a simple struggling system that's called AI, and it do not distinguish features or annotations of each application. It only do the resources allocation. That was preparation for T4. Well, in 2015, we want to have a better resources management and allocation of this kind of resources, and that was quite complicated and complicated systems. And we want to do our attempts in each business unit, and we made AliSwarm and Zoe system with the e-commerce system. Well, in 2017, we made attempts on these 3 systems, and we want to combine these advantages and to make a new system to be the major strength for Alibaba to support our business. So in 2017, we launched the Sigma 2.0, and including most of online services of Alibaba. Well, in early 2013, we launched and we started the work on Sigma 3.2, which will Kubernetes as a core component. I will introduce later. While Sigma itself is actually beyond the concept or the range of Kubernetes. Actually, it's a more comprehensive cluster management. While for his work, it can be simplified into the following levels. And the first, it will do the network storage and compute, do the abstract of this so that we can have the visualization of that aspects. And above that, we have the online scheduling. That is to say, once user will submit the resources request, we'll do kind of struggling. And we also have the offline schedule that to respond to November 11 scenarios, that we can expect that kind of scenario and expect the total volume and do the planning so that we can have an overall optimal plan. And when we deal with the offline scheduling, and we also use various methodologies to do such kind of arrangement. Well, above that, we want to dynamically management and regulate this kind of resources. As I mentioned, the batch job and online service, they are not the same sensitive to the resources. So if they run on the same resources, they will have some competition and may cause some latency. So we will to test before if these resources may compete with each other. We want to avoid that so that ensure the efficiency and stability. We also have such kind of auto scaling, and we want to scale automatically according to customers' need. And in this way, we want to avoid the overhead of resources, to avoid the static resources or resources wastes. For example, in the peak time of each day, the system will automatically lift up the volume to respond to the rise of the volume without human interference or operation. And we also have the resources utilization analysis. And above these supportive tools, we also have some higher level management tool like chargeback. Well, chargeback aims to monitor each business unit or each team of the costs of each project so that we can push them to optimize this kind of services. And it is a charge function. Besides that, we also have the capacity planning, because we are the major part of Alibaba Group architecture. We have a global view or an overall view of the resources demand of Alibaba Group, and we can expect resources demand in the following years, and we can calculate what kind of models or machines that we wanted to or expected to purchase in the following year. So Kubernetes will be an engine, but will not be all of the Sigma. Well, when I communicated with my colleagues, we want to clarify the relationship between Sigma and Kubernetes. Well, here I will introduce another topic. Maybe you have mentioned, you have heard of Fuxi scheduling system. Actually, we released a paper in 2016. Actually, it deals with mass calculation and struggling or cluster management. And we also want to integrate Sigma and Fuxi to make them co-work or co-location. That is to say, the same server can run both Sigma and Fuxi business so that the resources of this server can be better used. Since the job on Sigma and resources are different and quite complementary, and if they can co-location on the same server, the resources utilization rate will be increased. And you can imagine that the Sigma and the Fuxi deploy resources on each machine. They will deploy on the zero level, and we can ensure that the resources are manageable on each level. And in this slide, we can see that the testing results. Well, on the right side, we can find the average resources utilization rate is not that high. But on the left side, we can see that the peak value is quite high. And when we combine or co-location both online and offline services, we can see the overall utilization rate will increase by 30%, while the peak value will not be increased that much. So the result is quite accessible. And we can see that the correlation of Sigma and Fuxi can greatly increase the utilization of resources. And we can see the data, according to the data, the efficiency is increased by 30%, but for the deployment of machines or containers, it increased much more times. Well, for now, I want to introduce the architecture of Sigma. Previously, That was quite common with the control plan and the data architecture.
And there is a master component. And on the data plane, we have our node agent. So if you're familiar with the Kubernetes, there's an API server. Everything is communicated to the API server. So previously, we used etcd as the communicator, so everything will be reflected through the etcd. And also, we have a scheduler. For scheduling decision, we have an API server as well. It's different from the KPS. It can directly control the Pod D. It's like a Docker D. You can imagine it as some functions. We put certain functions of Kubernetes into the API server. So it is also a node executor. So the API server undertakes more functions. And as you can see, there is no controller role here as well. So for certain jobs, it is also included in the API server. And for the node, the previous
然后我们也有我们的这 provisioner， 它来去管理其他的这些虚拟资源的用户。这个是大概之前这个 Sigma 的一个架构情况。然后我们之前那个 Sigma 核心的架构，其实我们遇到的这个几个问题。首先，我们第一个问题呢是遇到的是我们认为这个 API server 本身呢是一个比较 monolithic 的一个 design， 一个巨型的 design。那刚才我也提到，其实它去容集了 API server、resource manager、controller 和 node executor 几个角色为一身。那这个样的架构会导致这个系统本身比较难去 scale。那比较难去 scale 体现了几个方面。那第一个方面呢是从我们的这个性能方面来讲，其实它会做很多的角色，所以说你让它去支撑很多的这个 number of machines， 才会遇到这个性能的瓶颈。那第二个呢，可能更多的是一个人员的瓶颈，因为我们可以知道，就这几个 API server、resource manager、controller 和 node executor， 实际上它有不同的职责。那我们也希望有不同的团队能去管理，来去做这些不同的能力。但是如果把它做到以同一个 code base， 以同一个 release cycle 进行 release 的话，其实团队协作还是比较难以去 scale 这个团队。其实遇到的问题跟我们就大家知道的 microservice 遇到的问题是一样的，所以我们希望能把 API server 呢更进一步去 break down， 把每一个模块都每一个团队呢专门去负责。那这样在开发的时候呢，我们更容易去进行迭代。那我们遇到的第二个问题呢是，之前那个 Sigma Core 我们在 design 的时候呢，更多的是面向我们之前的这个运维的模式，也就是以 failure 的模式，就是说是 event driven 的，而不是一种这个像 K8S 一样是 declarative 的一个 design。那我们每一个新建这个容器的这个操作呢，实际上我们几个这个 component 之间呢都是以 action 的形式来进行交互的。那这里面也会遇到一个问题，就是说，如果你有一个 action timeout 或者它 failure 的话，那其他的这些组件都要进行这个 rollback， 那你的 failure recovery 实际上是比较难做的。所以说，我们也希望能有这个更好的利用像 K8S 这样的 level trigger 这种功能来去做一个 declarative 的 design。所以基于上面呢，我们就在考虑这个是时候给那个 Sigma 来去换一个新的核心了。那当时我们也考虑过几种这个 solution， 比如说我们自己去从 scratch 来重新写一个这个Sigma 的核心组件，或者我们用业界比如说比较流行的 solution， 像 Mesos 或者 Kuberenetes。那最终我们选择了 Kubernetes， 那其实有这几个主要的原因吧。第一个原因我现在也提到，我们认为就是 Kubernetes State Oriented API 呢，对于这个 failure recovery 也好，还是对于自动化运维也好，都是比较好的一个思路。因为用户可以去跟你 describe 它的这个状态，那这样呢，你更容易的去帮助用户来去做这个 automated 的这个 recovery， 或者帮助用户去自动化的编辑这个状态。那另外呢，每一个组件与组件之间，就是内部组件之间也以这个 state 的形式来去 communicate， 那我们更容易去 recover from 某一个组件的这个 failure， 所以这个可以让我们的系统呢更加强壮。那第二个呢，也是 Kubernetes 本身的 design 呢，它是比较这个容易 extensible， 而且是比较 modular 的。那它通过 API server 呢来去 decouple 所有的组件。那比如像调度器也好 ，controller 也好，你都可以自己的任意添加或者任意的这个替代。那 Kubernetes 呢，也有这个像 CRT 这样的 design。那外部的团队其实也可以利用 K8S 这套呢，来在 K8S 上拓展出属于它自己的 customized 的这个功能。所以我们 Sigma 团队呢，也可以把 我们本身的 Sigma 这个 ecosystem 建立起来，让外部团队和我们去进行一个共建。那另外呢，我们也认为 Kubernetes 这个社区 CNCF 的这个社区呢，是现在最为这个 thriving 最为有活力的这么一个社区和最有活力的这个 ecosystem。今年这个中国这个KubeCon 3000人，在西雅图 KubeCon 可能将达到7000人，所以这个社区我们也是非常喜欢，所以我们希望和社区呢一起去共建一套平台，而不是我们自己去弄一个这个闭源的系统或者 private system。那最后下一点呢，也是我们在招聘市场呢也看到，就是在国内也好还是在国外也好，越来越多的工程师实际上已经有了这个 Kubernetes expertise， 所以说我们也更容易的去找到工程师来帮助我们演进系统，或者帮助我们在阿里巴巴内部把我们 Sigma 的生态或者围绕 Sigma 的系统变得更robust，变得更这个有活力。那最后一点呢，也是我们认为通过这个采用 Kubernetes 作为新的底盘呢，我们更容易 onboarding 我们的 new customer， 让我们新的用户呢去熟悉我们的 Sigma 的系统，因为我们的所有的 API， 我们的所有的这些功能呢，实际上都是开源的，有比较好的这个 documentation。大家如果想去在这个系统上build自己的新的功能呢，也会相对于容易一点。那这个呢，也其实减少了我们团队的一些工作量，我们不用去对每一个这个 standard API 呢都要去对用户进行解释。那下面呢，我也想讲一讲我们是如何把我们这个旧的系统慢慢的向这个 Kubernetes 上 migrate。因为刚才我其实讲到 这个我们想换掉的只是这个 Sigma 的核心的部分，其实和这个 Sigma 上游呢还要是有很多的这个系统，所以我后面也是讲说我们怎么把 Sigma 核心的利用这个 Kubernetes 成为它新的地方。从这个部署上看呢，我们其实有两种方式。第一种方式呢，就是说我们去独立的去做出一个 Kubernetes 这么一个小的集群，然后慢慢的把 Sigma 上的业务往这个 Kubernetes 的这个集群上去转移。那这个呢，要求我们有两个这个集群，然后每个集群有独立的这些 machines， 然后 K8s own 这些 machines， 然后之前的 Sigma own 另一些 machines， 然后一点点把这个 workload 进行转移。那我们还有第二种方法，就是把 Sigma 和 K8s 呢，实际上呢部署在同一个集群中，然后每一个 machine 上既可以跑 K8s 的 workload， 也能跑 old Sigma 的 workload。那这样的话呢，我们就不需要去人为的去分割出两个集群。这样的话，我们的升级过程可能可以做得更平滑。经过这个我们的考虑呢，我们还是希望去采用这个第二种更平滑的过程。那虽然说第一种大家看起来可能会更干净，而且有更少的这个，对于我们来讲有更少的这个工作去做，但是对于阿里巴巴的环境，因为我们日常的这个资源的分配率其实已经很高了，我们很难腾出来几台码时间说专门去部署 K8s， 然后让业务一点一点的迁过来。那这个产生的 overhead 其实在资源上是我们难以接受的，所以说我们采用这个第二种方式。而且第二种方式好处也是说，我们可以一点一点来去做迁移，然后对于我们的工作量上来其实我们也是更加可控的。所以基于这一点呢，我们其实把 K8s 的 scheduler 呢换成了我们自己的 scheduler， 我们做了一个叫做 Unified Scheduler 这么一个这个调度器。那这个调度器的功能是什么呢？这个调度器的功能其实它可以同时的理解之前 Sigma 在整个集群中部署的这个资源，以及 K8s 在整个集群中部署的资源。那每一个 node 都会把自己的这个资源对这个像这个 K8s 也好，还是 old Sigma 进行上报，然后呢，我们的这个 Unified Scheduler 其实会做一次这个汇总。那当新的这个请求来了之后呢，那我们的这个 Unified Scheduler 因为它知道每台机器上的 Sigma 资源和Kubernetes 资源，它还是可以去做出一个很好的决策，不会去 overload 的一个这个机器。所以说我们利用这个 Unified Scheduler 作为了之前的 Sigma 和我们 Kubernetes 这么一个中枢。那如果我们去更细致的看一下我们的这个 Unified Scheduler 呢，那实际上我们是把这个 Kubernetes Sigma 以及我们后面我们做的一个 simulation 都变成了一个 platform。那这个 platform 呢，做的功能只是把这些数据，就不同平台的这个 API 的数据拿过来，然后他们这个 platform 呢会翻译成一个我们这个 schedule core 这个核心层能够理解的一个 request。那真正的调度功能呢，实际上是在我们 schedule core 里面去完成的。所以对于 schedule core 而言，它并不知道上层的这个 platform 到底是 Kubernetes 还是 Sigma 还是一个 simulation 还是一个假的。那这个 cluster state 呢也是一个统一的 state， 在这个 state 里面呢，我们其实也存储了 Kubernetes Sigma 和 simulation 的这个信息。那这些信息呢也是一个统一的这个信息，我们把这个 Kubernetes Sigma simulation 都做了翻译。所以说我们利用这个架构呢，来去屏蔽，在这个 scheduler 上屏蔽掉上层这个资源的这个异构性。 那另外一个，我们去做这个自己的 schedule， 还有一个原因是因为像 Kubernetes 这样的这个系统，我们认为它对资源的分配的力度呢，其实是不太足够的。因为大家可能知道 Kubernetes 在分配 pod 的时候，它只会说 OK 这个 pod 到这个 node A 上面去，或者这个 pod 到 node B 上面去。但是对于我们来讲，其实我们有更多细粒的资源来需要去分配。比如说，我给大家举一个这个 CPU 的例子 ，CPU 其实会有这个本身的这个 micro topology， 就是它的这个微架构。在微架构上，它有自己的 NUMA core， 它每一个这个 physical core 上，其实它还有自己的这个 logical core， 自己的 hyper thread。所以对于我们来讲，我们在分配真正给 container 给容器分配这个 CPU 资源的时候，我们会考虑到更细粒度的这个 CPU 结构的分配。所以我们分配的时候，我们可能会说 OK， 我这个容器一会分配到，比如说这个 core 0上面的第0个和第16个 core， 我们会有非常细粒度的分配。所以说 K8s 也不是能完全，它的也不能完全满足我们的功能。所以我们在做的时候呢，也是在我们调度器在做完这个操作之后呢，我们会在这个本身 core 的 annotation 里面写清楚它在这个 node 上需要的这种微架构资源到底是什么。然后我们也对 Kubernetes 进行一些改造，让 Kubernetes understand 这些 information， 最终在做这个本期的 C group 的管理的时候，把这些信息呢都去进行管理。那我刚才讲了讲我们在调度器上的一些这个改造工作，那下面我也想讲一讲我们在这个 controller 上的一些改造工作。那我们在阿里巴巴现在目前阶段也并没有使用这个上游的这个 deployment 也好，或者 regular side 或者 stable side 这样比较标准的这个 controller， 而我们使用了这个一个自己的这样的 in-place side 的这个controller。那 in-place side controller 主要的这个区别是因为我们需要去支持这个 in-place 的这个 upgrade 操作，我们不想说在每一次对容器进行升级的时候呢，都要去把这个容器进行一个重新的调度，所以说我们需要做 in-place 的这个操作，然后包括我们这个本身的 in-place 的 control 它也支持更细腻的这种 control upgrades， 就是你什么时候开始 upgrades， 到底哪台机器需要 upgrades， 哪台进行停止。那我们也会支持这个 scale down by ports， 就当你去 scale down 的时候，我们可以说有一些这个 port 本身现在健康度已经不是很好，我们优先把它去 scale down。然后我们对这个 K8s 本身的这个部署工作呢，也做了一些这个探索。因为阿里巴巴我刚才也提到，我们在一个集群内可能有数个 Kubernetes 的部署，那我们有数个这个集群，如果我们全都以手工的方式来去部署 Kubernetes 的话呢，成本是很大的。所以说我们做了一个 Kubernetes 的这种方式。那 Kubernetes 的方式简单来说就是我们去部署的一个原集群，然后在这个原集群 K8s 上面去部署业务 K8s 集群的这些 master component， 然后利用 K8s 的自动化管理功能呢来去运维这些业务集群的 K8s master， 然后我们也做了 Kubernetes operator 来去完成这些自动化的运维的工作。那通过 Kubernetes operator 呢，我们其实把我们的这 deployment time 减少至少10倍，我们也能让 Kubernetes 的运维工作自动化起来。然后我们因为也有一些 CI/CD 要跑，每次做 Kubernetes 测试的时候，我们要可以非常快的非常的这个稳定。那除此以外呢，我们其实刚才也提到了这个蜻蜓这个项目，因为我们这个集群规模比较大，而且在发布的时候经常是几千个容器一起进行发布。那如果说我们是采用传统这种中央的这种下载image的模式呢，是非常容易把中央的 storage 打爆。所以说我们也希望有这个 peer-to-peer 的这种image 的这种分发的模型，然后在K8上我们会在每个 node 上以分散的形式来去部署这个 peer-to-peer 的这个安排，然后我们会有 super node 以这个regular side 的形式部署这个 super node 来去完成整个部署和运维的工作。那我们最近也是刚刚把这个 Dragonfly 以这个3box 形式呢捐给了 CNCF， 我们也希望能和社区呢一起去共建这个 Dragonfly， 把 Dragonfly 做得更通用，不光是能适应像阿里巴巴这样超大规模这种公司，也能适应小公司或者中型企业的一些这个部署。我们希望把大家的对在 image 这个 distribution 的成本降下，效率进行提高。那另外我们做的一个工作呢，叫做这个 image， 也就是我们阿里巴巴我们再去做这个upgrade 的时候呢，实际上经常有一个分批的操作。那分批的操作，如果说我们的 image 每次都是在每批开始的时候呢，才去做这个 image 的这个分发的时候呢，时间是比较长的。所以说，我们去希望把这 image 本身的抓取工作变成一个 pipeline。
Image itself can be a pipeline work. So for the second batch, you just need to wait for the readiness of the first batch before the second batch started. So for this image preheat, we actually express it through CRD. Each node know what the preheat image is, and you can download the image to the local in advance.
然后我们阿
In Alibaba, stability is very important to us. The cluster itself also needs to have certain functions, and we need to optimize them as well. So data is very important to us. We actually established such a data pipeline for data collection.
To support VPA and HPA, I will just skip the details. Well, I will elaborate a little bit. With Node and the central master, we collected the collector to collect external information. Well, for now, we have deployed the Kubernetes for 3 months and with 10,000 nodes and 1,000 nodes and 10,000 pods. That was the scale. For now, the Sigma is actually account for a little part. Well, we believe in next year we want to promote the Sigma and use Kubernetes as a core component. Well, for the future, we will have the following challenges. First is about the reliability and stability. Previously, Sigma was self-governance and controllable, and most decision-making logic was concentrated on the central API collector and were easier to manage risks. But for now, the decision-making has been decentralized into different nodes, and we want to avoid such clocks. And if one decision maker have a bug, it will not affect the whole system, and we want to address that issue. And for the second challenge is about a large cluster. For now, the Kubernetes only support a limited amount, so how to address the scalability is one of the major challenges that we might meet in the future. Well, for another challenge is about the upstream compatibility, and we have such modifications, and we want the Kubernetes can both benefit the welfare of the upstream and it can be stable and avoid repeating the work. We'll launch the new version of Kubernetes every year. Well, for the fourth, I believe this is not the whole platform of Alibaba, and we believe they have many past platform in upstream and want to employ the whole ecosystem and to make the work better, and we want to cooperate with the upstream platform so that we can benefit all the worker in Alibaba Group and reduce the development costs and increase development efficiency. And that's all my speech. Thank you. Due to limited time, do you have any questions? 因为时间到了，我以为要说不讲了，我都丢2开始了。Please use the microphone. Hello, I want to raise a question that is to see large cluster. Do you have any suggestion for use etcd on large clusters when we operation the large clusters? Do we need to operation only one segment and to give enough or sufficient width, or we need to separate or management separately to maintain each cluster? Well, I believe at the beginning I recommend you to upgrade the hardware of the etcd and make it reliable and have a good performance so that you can reduce the maintenance costs, and you do not need to change the Kubernetes, make any changes to Kubernetes. And secondly, as I mentioned, the Kubernetes will limit it to onto one container, and if you want to change the CRD as upstream and you want to make the other resources rest on the other part of the system, and that will be the trend of the development path in the future. But we still want that to maintain in one container. And I saw that there's some discussion that they talk about events. Well, we have already mentioned that. Okay, due to 1 minute left, there's only one question. Now I have an easy question. Well, since Sigma is in the middle level, well, in Kubernetes, we have many services, and among each service, they have kind of dependencies. So among this services, do you have any countermeasures for Sigma? If one service failed, so maybe the whole service vertical line may be broken. So do you have some mistake tolerance mechanism to respond to that issue? I believe this is a quite good question. Well, for now, we want to offer the reliable and stable resources. While in Alibaba Group or the upstream and PaaS platform, we have many stable mechanisms. And for now, the abstraction or virtualization of each service, we do not use Kubernetes and we use a middleware. Well, for now, how to connect each kind of resources and check the health of this kind of virtualized resources, they will be expanded or explored in the next phase. As you mentioned, you called about the correlation among each services. I believe this issue will to be addressed by the middleware. Well, for now, Alibaba's central package actually will want to think and work out this question, work out this issue together with our partners. So due to limited time, I will conclude my speech.